back to methods 1 and 2 with Mr. Hannah. And in this video, we're gonna be looking at the null factor law and solving quadratics. But before we do that, I want to show you some graphs of these particular examples, example 3, 4, and 5, that we've completed the square with. And I'll show you why in a moment. So let's look at some graphs of that. We'll get out our CAS. We'll open up a graphs page. Add a graphs page. Okay, so first we'll start by graphing this example 3 graph here. So we've got x squared plus 6x plus 7. Alright, let's graph that. Alright, there we go. So, unsurprisingly, it is a quadratic graph. And it's got two intercepts, one here, one here. You notice that it's symmetrical, and it's got a turning point, and it's going in that direction, kind of like a smiley face, I guess. Okay, so one thing we might be interested in is what are these x-intercepts here? What are they? And we can get our CAS to do that. Let's analyze this graph. And what we're doing is finding the zeros. Okay, the zeros just means, I'll explain why that's 0 in a moment. But the zeros is the intercept, so first ask for a lower bound. So put something that's lower than this intercept. Like if I put it here, that's higher than the intercept, so it won't show me. And an upper bound, well, let's do this one here. So here is our first intercept, minus 4.14. And we can repeat that same process again to find the other intercept if we want to. 0, lower upper bound, and there's our other one right there. Okay, let's now try example 5 and find the intercepts for example 5. So this is the example, remember, where we weren't able to fully factorize it. So let's open up a new graphs page. Okay, so x squared minus 10x plus 26. X squared minus 10x plus 26. Alright, there we go. So it's the same sort of shape, if you like, as our last graph, but there are no x-intercepts here. Still has a turning point, still symmetrical, still a smiley face, no axis intercepts. And the reason why is because we were unable to fully factorize. Because it's a plus 1, we weren't able to do the difference of perfect squares trick. Alright, so what we're going to be doing is investigating why these two axis intercepts were these 2 points here. And it's related to why on the calculator, we go analyze graph, the intercepts are called zeros. That's because, oops, let's get out of that. That's because we know the x-intercepts are when y, the y-axis, equals 0. So the y is 0, y is 0. In other words, over here, to find the intercepts, we're interested in when this equation equals 0. So when that equation equals 0, that's when we're finding our intercepts. So this is why we had to factorize as well, because to find when this equals 0 is very difficult when it's in this expanded form. But when it's in factorized form like this, finding when that equals 0 is much, much easier using the null factor law. Basically what the null factor law says is one of these two factors, either this one or this one, must equal 0. So either x plus 3 plus the square root of 2 must equal 0. So either x plus 3 plus root 2 equals 0, or x plus 3 minus root 2 equals 0. That is the null factor law. So for this equal to 0, let's shift everything except x onto the other side. So I'm going to subtract 3 plus root 2 from both sides. So now I've got x equals minus 3 minus root 2, or x equals minus 3 plus root 2. I've put everything from this side onto the other side. So let's see what these two values are, and hopefully what they are is over here, minus 4.41 and minus 1.59. Let's see if that's true. Let's do this in a calculator page and just find out what minus 3 minus root 2 is. Minus 3 minus root 2. I want the inexact answer, please. There we go, minus 5.41, and we've got more decimal points here because this third is just going to keep on going. And let's look at the other one too, just to confirm. Minus 3 plus root 2. This time I'll ask it to give me the inexact answer straight away. There we go. So that's the same two. You'll notice those two answers there. Put those in your mind right now, and we'll shift across to our previous page. There they are, those two same values, although these ones are rounded off. Okay, so that's the null factor law. Let's look at it in a few different examples. Yes, sure. Okay, so the null factor law. Null factor law. Okay, so we've learnt that solving an equation is the same as finding the x-intercepts. So if something were to ask to solve x squared plus 7x plus 10, solve that equals 0 is the same as saying find the x-intercept of this equation. Now for this one, what I'm going to do is use the thinking about it method. So 10 has factors of either 1 and 10, or minus 1, minus 10, 2, 5, minus 2, minus 5. So hopefully you can see that the factors that add up to 7 are 2 and 5. So I can factorize this to x plus 2, and x plus 5 equals 0. Okay, so the null factor law states one of these factors must equal 0 for this to work out. So we have x plus 2 equals 0, or x plus 5 equals 0. So here we put 2 to the other side, that gives x equals minus 2, or put the 5 to the other side, x equals minus 5. There you go, so you can either write your answer like that, or some people are a bit lazy and write x equals minus 2 or minus 5 like that with a comma. Either way is fine. Okay, let's try another one. Let's try an even easier one. Solve x squared plus 8x equals 0. Okay, so here first we'll remove our common factor. So this is a common factor one. Remove x as a common factor. We've got x plus 8. So here that equals 0. So we can say that either x has to equal 0 or x equals minus 8. Minus 8. There we go, that's that one. Let's change colour again. So I'll do one or two more, why not? Solve 2x minus 3 equals 0. Here we go, so this is just sort of part of one if you like. So for this to equal 0, first I'll put the minus 3 to the other side. So I've got 2x equals 3. Now divide both by 2. So x equals 3 on 2. There we go. So that's our x-intercept there.